Day 135, equivalent capacitance examples. All right, let's go through some of the misconceptions on this one first. We need to combine all these capacitors. They're labeled C1, C2 for capacitance. These are all either 6 or 4 microfarads. They left off the F for farads. But if you look closely here, on the far right, we have a 6 microfarad capacitor. What the temptation would be here, if you're first doing these, you might think that these 3 right here are in parallel. They look like they're in parallel. The problem is that, well, they're not in parallel because of the fact that these and these exist. If any one of those 4 capacitors in those blue circles existed, if any one of them existed, the 3 in the red circle would not be in parallel. But if the 4 in the two pairs in the blue circles, if all 4 of those were gone, then yes, the 3 in the red circles would be, in the red circle, would be in parallel. Okay, so I need to erase those. So those are not in parallel. They look like they're in parallel, but they're not. Now, the other thing that looks like is it looks possibly like these 3 right here are in series. But once again, they're not, because there's some other connections within, or where these 2 green dots are, they're here and here. Because there's connections there, those 3 are not in series. So a lot of this comes down to practice and then people explaining it to you. So where you need to start on this one, if you've had a lot of experience, you'll see this right away, is way out on the far right. If you look at the 2 dots out here, this dot here is called a junction, and this junction right here, if I were to go from, say, point A, junction A, to point B, there's 2 ways to do it. If I'm going, say, starting from A all the way along the top, and the big A on the left-hand side, and start at A, and then go around, I can go around this way and get to B, or I can go around this way to get to B. So those are 2 pathways. Those 2 pathways I just outlined in blue are parallel pathways. And the one on the right is, it contains 3 capacitors. Those 3 are in series. So the 3 6 microfarad capacitors on the far right over here, I'll just circle them. These 3 capacitors are in series. So I'm going to combine them by the series rule. 1 over C total equals 1 over 6 microfarads plus 1 over 6 microfarads plus 1 over 6 microfarads. And I punch into my calculator, I will get C total, the combination, will be 2 microfarads. So what I want to do is redraw this diagram now and replace that combination of all 3 of those with 1. So the diagram will look like this. And I've put the new capacitor that replaces the 3 6 microfarad capacitors with a 2 microfarad capacitor on this new diagram, and I left all the units off of this diagram. But right now I'm looking at the 4 and the 2 on the far right side of this new diagram that I just drew. The 4 and the 2 are in parallel with each other. All right, they join a couple of junctions, that those points A and B. So those blue dots I'm drawing are still point A and point B, like I pointed out earlier. Once again, to go from point A to point B, I can either take the path through the 2 microfarad capacitor or through the 4 microfarad capacitor, and those are two distinct capacitors between those 2 points. They're in parallel with each other. So I use the rules of parallel capacitors combinations and simply just add 4 plus 2 and get a 6 as the combination. So I'll put those together and draw the new diagram. The diagram is shrinking. I've combined the 4 and the 2 microfarad capacitors and get 6 because in parallel 4 plus 2 is 6. And you'll start to see some patterns emerging. This problem was set up to be quick. Once you get going here, it's quick because now you'll see the patterns repeating itself. On the far right hand side, once again, I have 3 6s in a row that are in series, the 2 reds and the 1 blue on the far right hand side, kind of like what I had at the beginning of the problem. And it's used the same math, 1 over 6 plus 1 over 6 plus 1 over 6 equals 1 over C total. So those all combined together will give me 2 microfarads again, and here's the new diagram. So I think we can see here now that the pattern is repeating itself. Now I have on the far right hand side a 4 and a 2 in parallel. You add those together, you're going to get 6 again. I'll draw that diagram, but you can kind of see where this is going, I hope. We're just about done. The 4 plus the 2 is the 6. The new capacitor replaces the other 2 that I just put together. And now I have a series from the original point A to point B, 3 in a row that are all 6s. They will combine to give us 2 microfarads. So I'll do the last diagram. Final answer for the combination of all these capacitors is 2 microfarads. That's simplifying this circuit down to its most basic single capacitor that would be equivalent to all of those other ones put together. 2 microfarads. Example number 2. Once again, we're trying to combine everything here and find the equivalent capacitance between the 2 labeled points A and B. Once again, these are all microfarad capacitors as they are numbered. The question is, where do you start? So once again, with practice, you'll see this. And what I can show you is up here on the top, these 3 right here in this red circle are in a row. They're in one branch of a wire from this point here, this blue point that I'm highlighting, and this point right here. Actually, I can use a little pointer. From this spot right there, if I go along there to this spot, that's one train or one wire where you have 3 in a row that are in series. So I'm going to add those up. There's 6, 6, and 6. So it's the same rule we just did on the previous page. It's 1 over 6 plus 1 over 6 plus 1 over 6 equals 1 over C total. Those will combine to give us 2 microfarads. So I'll draw that diagram. Here is the replacement diagram. The 3 capacitors at the top have combined to give me 2 microfarads. So that one capacitor replaces all 3 of those 6 microfarad capacitors. All right, so what we have now, once again here, from experience, from this point right here to this point right here, I'll use my fancy pointer, from that spot right there, going along over to here, that's one branch if I go this way and down and over, the 2 and the 4 are in parallel with each other. So you're going to combine the 2 and the 4 in parallel. That's just 2 plus 4 gives me 6. So the new diagram looks like this. All right, I combined the 4 and the 2. That gives you 6, 4 plus 2. So I replace both of those with one capacitor, and I'm trying to continue with the integrity of the rest of the circuit as it's sort of drawn here. So this new diagram is basically a simplified version of the one above it. And so now we're looking again for where is there either a parallel or a series combination that I can simplify. And I see it right along here, this branch right here that I'm tracing out is 3 6s in a row. Once again, they made it easy on us. They're using the same numbers over and over, but if they were like a 6 7 and 7 or 6 8 9, it doesn't really matter what the numbers are. You just use the rule 1 over 6 plus 1 over 6 plus whatever the other one is to get 1 over the total. But here we've done this one several times now. Those 3 capacitors will combine to give me 2 microfarads. So I'll draw that. So there's what the simplified diagram looks like when you combine the 3 6s in a row. They become 2 microfarads in combination. The 2 now is in combination, parallel combination with the 4 right below it. So I hope you see the pattern now. The 2 plus the 4 will give us 6, then I'll have 3 6s in a row again. So there's just 2 steps left. I'll draw both diagrams here. Well, here's the first combination. The 4 plus the 2 gives me 6, so I have 3 in a row. So I do the same old 1 over 6 plus 1 over 6 plus 1 over 6. Gives me the final, which will be 2 microfarads. Here's point A, point B. Final answer, 2 microfarads. That's what I was looking for. The combination of all the above comes out to be the same answer as the first one, even though it's a significantly different looking connection, which it is. It still boils down to 2 microfarads because they're using 6 and 4 microfarad capacitors in a very clever way to give you the same answer. But you don't always get the same answer. You can certainly hook these capacitors up in a way that will not give you 2 microfarads. There's basically almost an infinite, close to an infinite number of ways you can hook these up. Check that. It wouldn't be infinite, but it would be a high number of possibility, different ways of hooking them up. All right, example number 3, and it's a little fuzzy here, and I filled the numbers in for you on the sheet, or I showed you where to put the numbers in. Bottom line, on the very top there, you have capacitor number 1, capacitor number 2. In the dead center, you have capacitor number 3, and then basically on the bottom, you're going to have capacitor numbers 1 and 2. Let me fill this in like you have it on your sheet. I'll put the numbers on. Let me pause for a second. So here's the diagram I intended. There's 5 microfarad capacitors at the very top. At the very bottom, there's a 5 and a 10. And there in the middle, so to speak, there's a 10, 2, and a 2. It's a little fuzzy. And then I have point A and point B. I want to find the equivalent capacitance. I want to put these capacitors all together. So the hardest part, once again, is to get started. Where do you start? And in this case, it's one good place to start is here, really at the bottom. The 5 and the 10. You look over here, this 5 right here, and that 10 right there. Hey, how do you like my little pointer there? It's like a lightsaber. The 5 and the 10 are in parallel. They are alternate pathways to get from that spot, like right there, to this spot over there. They're in parallel with each other. So I'm going to combine those by the parallel rules. The 10 plus the 5 will give me 15. But at the same time, I'm going to look at the top up here. Let me change my pointer to a different style. All right. So this capacitor up here, well, here's a point. At this point right here, I can go around this branch right here. Those 2 capacitors right there in that branch, which one pathway, the 5 and the 10 are in series with each other. So that's a piece I see right away. Also on the right-hand side, the 5 and the 2 over here are in series. So I'm going to do 3 steps in one, basically. The 5 and 2 are in series. The 5 and the 10 are in series. And this 5 and 10 right here, down at the bottom, are in parallel. But I need to draw, or to calculate, let's do the 5 and the 10 on the top left. In other words, 1 over C total. equals 1 over 5 plus 1 over 10. Doing the math there, C total turns out to be, let me find my calculation, 3.33 microfarads. In the upper right, I have a 5 and a 2. 1 over C total equivalent combined equals 1 over the 5 plus the 1 over the 2. And if I do the math there, that comes out to be 1.43 microfarads. Total capacitance, 1.43 microfarads. And then on the very, very bottom, down by point B, that's going to be parallel. So just add those up. 5 plus 10 is 15. So let me draw the new diagram. Here's the new diagram with the new values without the units. And let me also say this. There's not a rule that says you have to start here with a parallel, here with a series. Every problem is unique. In this case, we did 3 steps in one. The previous couple problems we did, we could only really do 1 step at a time. Here we had 3 different parts here that could be done separately. So I did those separately, but then combined them in 1 step. So I have all the new capacitors down here at the bottom, all in blue. Those were the combinations that I calculated as I went from the first diagram to this second diagram. And now, hopefully you can see this in the middle of this problem, I have 3 capacitors in parallel, the 3.33, the 2, and the 1.43. Parallel is nice because it's just arithmetic addition. You add those 3 numbers up, here's our new diagram. So the 15 microfarad capacitor stays the same, and we have the 3 combined into 1 just by adding, and you 3.33 plus 2 plus 1.43 gives you 6.76. Now we have an obvious series situation, and all you do is, once again, the 1 over C total rule of combinations for series equals 1 over 6.76 plus the 1 over 15, and you end up with C total equals 4.7 microfarads if you put the units back in there. And then you draw your diagram. All the problems we'll be doing will simplify to 1 single capacitor that is equivalent to all those other capacitors we started with. There were 7 of those. Those 7 capacitors will function the same way between points A and B as 1 single capacitor of 4.7 microfarads for the answer there. So there's what we're looking for. And just for the fun of it again, we need to go back to the laser pointer because that's so much fun. So there it is. Here we go. That's the answer right there. Look at that. 4.7 microfarads. The laser pointer almost burning a hole in this iPad. Not quite, but that's just so much fun. The noise is incredible. Anyway, that's how you simplify capacitor circuits. 3 good examples. See you in class.